All right, in this video, we're going to look at one final thing for lesson 3 as we define and use probability, and that is the idea of experimental probability. So most of the stuff when we work with probability, we think about it in terms of the theoretical probability, in that theoretically, if you flip a coin, you have a 1 in 2 probability of getting heads, or a 1 in 2 probability of getting tails. But if you were to flip a coin 10 times, it doesn't guarantee that you're going to get 5 heads and 5 tails, okay? So if we were to actually do an experiment, actually flip a coin or actually roll a die or actually pull cards out of a deck or whatever it might be, and then keep track of our results, that would be then using experimental probability. Okay, so when an experiment is performed that consists of a certain number of trials, the experimental probability of an event A is given by the number of trials where A, that event occurs, think of it as success, compared to the total number of trials. So it's the same definition of probability. It's just that we're actually going to do an experiment and then use that instead of just kind of assuming, well, 1 out of every 2 coin flips is heads, or 1 out of every 6 rolls of a die is going to be a 2. We're actually going to look at what happens if we were to do the experiment. So here we have some numbers that were found from rolling a 6-sided die 150 times. And we're going to use the table with the number of occurrences within that experiment to write down what the experimental probability of some given events might be. So, first of all, what's the experimental probability of rolling a 5? Well, according to the experiment, there were 27 5s that were rolled out of a possible 150. So 27 out of 150 would be the experimental probability of rolling a 5. Now, if you simplify that, okay, actually, well, let's not simplify that in just a second. Let's just compare that answer to the theoretical probability. The theoretical probability would be 1/6, right? Or I would say if you were to reduce this fraction and check it out, is this equal to 1/6? I don't know. Take a peek at it for yourself and find out. The next one, rolling an even number. Well, probability theoretically that would be 1 out of 2, but experimentally, according to this experiment, we've got 22 2s and 26 4s and 36s. Well, those are all the even numbers that came up when we actually did the experiment. So let's see, that's 48 plus 30. It's going to be 78 out of 150. Okay. And again, you can reduce that fraction and compare it a little bit to the experimental probability, the theoretical probability, which would be, again, like I said, 1 out of 2. So this is obviously not 1 out of 2 because 1/2 would be 75 out of 150. So it's close, but not quite. Next, rolling a number that's less than 5. If I was doing that one, that'd be anything less than a 5. That'd be the 1s, the 2s, the 3s, and the 4s. So if I do that one, I'm writing it down here. If I add up all these numbers, I end up with 93. You can check that. I'm just trying to save some time here. 93 out of 150. Compared to the experimental probability, which would be 4 out of 6, which you could reduce to 2 out of 3. Okay, again, not quite the same. And for the last one, rolling any number but a 3. Well, that's any number but a 3. That means 1 and 2 or all the rest of these. So add those all up, and we've got an experimental probability of 132 out of 150, which is not going to quite match the theoretical probability, which would be 5 out of 6, because there's 5 not 3s versus 1 3. So 5 6 would be our theoretical probability, but experimentally, this is what we came up with when we actually rolled the die that many times. So that's the difference between experimental and theoretical probabilities.